Welcome to ACE Physics. Today we will learn about interference of light. तो सबसे पहले interference क्या होता है? Interference means if two lights are coming and they are meeting at a point, so that is said to be interference. Interference के लिए source same होना चाहिए, monochromatic होना चाहिए. Monochromatic means light should be of same color or same wavelength, that is the monochromatic, and source एक ही होना चाहिए. So there is some example regarding the interference. First of all, I will clear it with the diagrams. Already it is on the screen, so just we have to see over here. This is actually main source is here. There is the main source, I will say. Then source of light is passing through two different slits. S1 is one slit and S2 is another slit. Here in diagram both are S1 and S1 only. That does not matter. Now this slit, from here light is entering and it is form one wavefront. Now this wavefront acts as the secondary source that again produces the wavefront like this. Then again this wavefront acts as the primary source. Then this provide the wavefront. Then further same way this, these all are the wavefronts. One is dotted line, another is dark line. So these all are the wavefronts of source S1. Now I will say, for this source, this is the wavefront, this is the wavefront dotted line, this is the wavefront, this is the wavefront. So all are the wavefronts. Now we are discussing over here, there are the two type of wavefronts. One is, I will say, as the primary, another is secondary. Dark line is the primary and dotted line is the secondary wavefront, we can say. So as we are observing over here, at this point one is dark line, another is dotted line, that is the secondary wavefront from source this, and this is from this. So as they meet at this point, one primary and one secondary, so that point is the dark point. Again here one secondary and another primary, so dark point. Same way dark point, dark point, dark point. So these all are the points at which the dark pattern is to be obtained. And in this case you will see this point, blue points are nothing but what? These are the bright point. Why they are bright? Either at this point, either both the dotted lines are meeting or both dark lines are meeting, dark lines. So if both are dotted or both are dark, then there is the formation of pattern of white, or we can say constructive interference takes place at that point. Yeah, white fringes are there and at this one dark fringes. So this red one is for the dark, blue is for the bright, dark, bright, dark, bright. Alternatively it is going to be formed. And bright points are the constructive interference, means where there is the combination of one dark and another dotted, that is the destructive. And for constructive, the points at which one dark and another dark, or both the brights, both the dotted are meeting, that point is said to be bright point. So these all are the patterns which are obtained by interference. So few diagrams are there, that is here. In this case we are observing the different lights are glowing at different points. So due to intensity of this one, due to intensity of this one, both are meeting at the point. So different patterns or brightness intensity is variable intensity can be obtained in this case. And it is one of the diagram, another is this one. This is also the impact of interference of light, as the sources of lights are going to create the different intensities. So due to that, there are the points at which there is a dark point and some points are the bright points. So this is also the example of interference. So first of all, what is the interference of light? Interference of light, the redistribution of light intensity due to superposition of two light waves is called interference of light. One source is this one, another source is this one. So two light waves superposition, one is एक intensities इनके ऐसे distributed है, इनके intensities ऐसे distributed है, and if they are meeting at different points, then that is said to be interference. So another example is here. This I was said a little bit, this is more clear. So this is the main source of monochromatic light, and source is producing the light, and light passes through the, light is kept at the focus of the convex lens. So light travels from here parallel to the principal axis, and as these light passes through the slits S1 and S2. Slit, what are the slits? Very fine holes that may be called as slit. So two slits are there, S1 and S2. So from here once again redistribution of light takes place, primary and secondary wavefronts are formed, and here also primary secondary wavefronts are formed, and they are meeting at different points. So this is the maximum bright point, or we can say these are the point at which the intensity is maximum. So this is the bright one, and this is the dark points which is minimum, of course. So minimum, maximum, this pattern is obtained over here. So I hope diagram part is very clear now. So on behalf of this one, we will find out the fringe width. So once again, what is the fringe width? From name it is very clear. Fringe width, the distance between two fringes. What are the fringes? Here minimum, maximum intensity of light is formed alternatively. So these are the fringes, and from the central point, this is central maximum or center point, from here maximum to minimum, whatever distance is there, this is called the fringe width. This is the fringe width, this is the fringe width, this is the fringe width. And in interference, distance between maximum and minimum points, or we will say dark and bright points, always will be same. This is very important thing that we have to keep in mind. So we have to derive an expression for the fringe width. तो fringe width already हमने explain किया. Now just we can say it is the same diagram, whatever is here. Fraction or the part of this one I have taken here. This is the screen at which interference pattern is to be obtained, and these are the two slits. Same way here two slits are there, S1 and S2, and this is the screen at which interference pattern is to be obtained, and distance between slit and screen is capital D. So capital D is the distance between slit and screen, and we have to find out the fringe width. I said, what is the fringe width? The distance between, fringe width is the distance between, suppose this is the central point, from central to next point at which the interference pattern is to be obtained, that distance is called the fringe width. So here suppose one source of light is coming from source S1 and that comes to the point P, another light from source S2 is coming and that is meeting or interfering at point P. So at this point there is the formation of interference pattern. Okay, and from central point, this is the center point, from here the interference at the point at which the interference is to be obtained, at that point whatever is the distance, that is called the fringe width. So y is the fringe width. So I will mention all the terms. What are the terms? Distance between two slits S1 and S2 is taken as d, and this is the fringe width. Y is the fringe width, and S1P is the path of source S1, S2P is the path of source S2, and if we will draw the perpendicular from S2, this distance S2M is called the path difference. So these all the terms I will mention. Y is fringe width, Y is fringe width, and S2P, S1 S2, S2 S1 is equals to D. It is the distance between two slits, distance between two slits. Then S1 and S2 are the slits, and S2M is the path difference. Now capital D, I will write it as, for the capital D we can write S1 dash is equals to S2 dash is equals to capital D, which is the distance between distance between slit and screen. I have mentioned this point as either this, and it is same as this, it is also D, it is also T. So all terms are very clear, of course. So few terms are there, whatever we will write one thing, this distance. If this distance is y, I will do one thing, I will draw this line, very small line, yeah, of course we can take at this point. Now it is fine, yes. So I can say this point is O, so I can write S1O is equals to S2O is equals to D by 2. So of course this term is D by 2, this term is D by 2, because overall distance is D, right? Further, what term will be, and it will be same as the O dash S2 dash is equals to O dash S1 dash is D by 2. So very important point is that what will be this distance and what will be this distance, that is to be calculated, because this distance is y and this distance is D by 2. So this distance will be y minus D by 2. So what is that? That point is S1 dash P. S1 dash P, it will be y minus D by 2. Very important thing. And what will be S2 dash P? S2 dash P. These two are very important. S2 dash P. S2 dash P. This distance. Of course, this is y and this is D by 2. So y and D by 2. Overall, this distance will be y plus D by 2. Correct? Y plus D by 2. So it is y plus D by 2. And as I said कि आगे डेरिवेशन के लिए ये दोनों स्टेप्स हमारे बहुत ज़्यादा इंपॉर्टेंट है. और एक्चुअली हमें क्या फाइंड आउट करना है इस डेरिवेशन में? वी हैव टू कैलकुलेट द पाथ डिफरेंस. पाथ डिफरेंस, तो एक सोर्स का पाथ ये है, दूसरे सोर्स का पाथ ये है, तो हमें निकालना है इनका पाथ डिफरेंस विच विल बी S2m. S2m is the path difference. So for that we will do one thing कि हम लोग ये पार्ट कैलकुलेट करेंगे S1p एंड S2p. S2p में से S1p को अगर हम माइनस कर देंगे then we will find out the path difference as S2m. It is very very important thing. So I will do one thing, I will copy the diagram because further diagram must be clear to us here. So as we can write about this diagram now from here, yes. So here what is to be calculated, we have to find out S2p minus S1p is to be calculated, and this is the path difference. This term is the path difference. So path difference is to be calculated to us. Path difference, very important thing. So for calculating path difference will require what things? We will require, first of all, I will say in triangle, in this triangle we will take two triangle. First this triangle, because we have to calculate S2p. For S2p we have to take this triangle, and for S1p we have to take this triangle. And if we will get S2p and S1p, then we can subtract them and we can find out the answer, means whatever is to be calculated. So in triangle, in right angled triangle, कौन सा राइट एंगल ट्रायंगल नाम दे देते हैं हम लोग, ओके, राइट एंगल ट्रायंगल S2 dash P, S2 dash P. In this triangle, what we will get according to Pythagoras theorem, we can write S2p square is equals to S2 dash square plus S2p square. What I did, I have to calculate S2p. So in this triangle, this is the hypotenuse, this one, S2p square is equals to S2 dash plus PS2 dash, PS2 dash, yes, PS2 dash. Now we can substitute the value S2p square, which is already we have to calculate, that will be equals to S2 dash, this is nothing but D, so it will be D square plus S2 dash P, this is Y plus D by 2, this is Y from here to here, and this is D by 2, so Y plus D by 2, so plus Y plus D by 2 to the whole square. We will expand it, so we'll get D square plus Y square plus 2Y D by 2 into D by 2 to the whole square. So this 2 and 2 will get cancelled, so we are getting S2p square is equals to D square plus Y square plus YD plus D square by 4. So S2p will be not, we will not write in terms of root, so leave it from here, that is sufficient at all. Okay, so we get one of the equation, I will say, not equation I will write, but just I am writing it as very important term. In next diagram, what we will need, what is the next part needed? Next part will be needed S1p, so we'll take this diagram, this triangle. So now in triangle S1 S1 dash P. In this triangle, what we will get? In this one we will get, again according to Pythagoras theorem, S1P square is equals to S1 S1 dash square plus S1 dash P square. That will get, this is capital D square plus this is y minus d by 2 to the whole square. So again S1P to the whole square is equals to d square plus y square minus 2y into d by 2 minus d square by 4, plus. So again 2 and 2 get cancelled, so we are getting S1P square is equals to d square plus y square minus yd plus d square by 4. So this term we get as S1P to the whole square. Now two different things we get. What we get? We get S2P square means this one and S1P square means this one. But we can't remove the square from here directly by taking root, because it will be so complicated. So I will do one thing. I will take this as equation number 1 and this is as equation number 2. So now subtracting equation 2 from 1, because we need S2P minus S1P. So subtracting equation 2 from 1. So now subtracting equation 2 from 1, what we will get? LHS will be S2P, 2 from 1 we are doing. So S2P square minus S1P square is equals to S2P this part minus this part. So once we will write all the terms, d square plus y square plus yd plus d square by 4 minus entire sign will change, as well do minus, so entire sign will change. This minus will be plus, and apart from that all terms will be minus. So just in single step I will write minus d square minus y square plus yd minus d square by 4. Now we can cancel all the terms, d square y square plus and minus this and this term. So we are getting yd plus yd will be 2yd. So this term will be, and of course this one a square minus b square type, so a plus b into a minus b. So we can write it as S2p plus S1p into S2p minus S1p is equals to, and what is remaining here, yd plus yd will be 2yd. This is 2yd, right? So further this we know, if already we know if point P is very close to, as we can see in this diagram, if point P is very close to O dash. If point P is very close to O dash means what? Already fringe width, as we'll do it practically, fringe widths are of order of 10 raised to minus 6 or 10 raised to minus 3. So it is very small. So for small values, what we have to keep in mind, that if point P is very close to O dash, then S2P and S1P, I can say that can be considered as the straight line. So this distance will be this distance. I can say if point P is here, just we are considering over here. So one will be like this, another will be like this. So this can be considered as D, straight line. So I will write if point P is very close to O dash, then I can say S1P is equals to S2P is equals to capital D. Then S2P is equals to S1P is equals to capital D. This is the assumption, I can say, whatever we are taking. So this term will be, keep that in mind, this term will be what? ये टर्म हमारा क्या हो जाएगा? S2P plus S1P will be D plus D, and what is to be calculate? S2P minus S1P is equals to 2YD. Now this will be 2D, so 2D into S2P minus S1P is equals to 2YD. So path difference is S2P minus S1P, whatever was to be calculators, that will be 2YD by 2 capital D. So 2 get cancelled, so we are getting as path difference S2P minus S1P is equals to YD by capital D. Terms must be clear to us. Terms must be clear. What we are getting? Path difference. All terms I have written. What is Y, what is D, small d, what is capital D in beginning I have mentioned. So we can say simply, what is S2P minus S1P is the path difference. Path difference is equals to YD by capital T. Very easy derivation. Okay, this is about the path difference. Now we have to write two conditions. In this one we will write two conditions. One is for the bright, another is for the dark. So I can say, because already we have mentioned over here in this diagram, as you can see, there is the minimum which is dark, maximum which is bright. So bright, dark, that kind of pattern is to be obtained. So what are the necessary conditions for the bright fringes and dark fringes? So conditions for the bright fringes and dark fringes, just I will differentiate it in two parts. I can say for the bright fringes, I can say for bright fringes we will get, okay, I will write two conditions. One is for bright fringes, and second condition is for the dark fringes. For bright fringes and dark fringes, what are the conditions? Path difference must be even multiple of lambda by 2. I will write that one. For bright fringes, path difference okay, must be equals to even, this word is very important, even multiple of lambda by 2. And for dark fringes we can say path difference must be odd, this word, odd multiple of lambda by 2. This is important thing. So two things I have mentioned over here. One is for this one odd multiple of lambda by 2, and for this one it is even multiple of lambda by 2. So we can say path difference. So path difference must be even multiple of lambda by 2 and odd multiple of lambda by 2. But we have, what is the path difference? Yd by d. So I can write for the bright fringes, path difference is equals to even multiple of lambda by 2. Once again I will write path difference is equals to even multiple of lambda by 2. So even number is 2n. So 2n into lambda by 2. But path difference we know. Path difference is yd by d. So this term will be yd by capital D, that must be equals to, here 2 and 2 get cancelled. So we are getting only n lambda. So n lambda. So if we have to calculate fringe width, so what is the fringe width? Y. So y is to be calculated. So fringe width y is equals to n lambda capital D by small d. So I can write this as very important formula for bright fringes. This is the condition for the bright fringes. So I can say where y is the fringe width. Y is the fringe width. Okay, so fringe width will depend on wavelength, distance between slit and screen, and what is small d? It is the distance between two sources, that we can say distance between two slits are using. Okay, so let us complete this part also. For the dark fringes, what we have to write? Again, for dark fringes, path difference must be equals to odd multiple. Now odd multiple. What is the odd number? Odd number is 2n minus 1 odd number into lambda by 2. If n starts with, where n starts with 1, 2, 3, and it could be 2n plus 1 into lambda by 2. दूसरा ये भी condition हो सकता है, but n will start with the 0, 1, 2. अगर प्लस आया तो 0 से स्टार्ट रहेगा. We can write both the things, but I will prefer to write this one. So we can say, therefore path difference is what now? Again, path difference is yd by d. So yd by capital D is equals to odd multiple of lambda by 2 is what? 2n minus 1 into lambda by 2. So y is to be calculated. So for y will be 2n minus 1 into lambda by 2 into capital D by small d. This is the fringe width for the dark fringes. Okay, this is the condition for the dark fringes. Okay, sorry, this is the condition for dark fringes. Okay, so this is one of the derivation for the fringe width, what we calculate, and two different conditions I have written. What will be condition for the bright fringes and what will be condition for dark fringes. Now I can say one thing, that this derivation is little bit lengthy and we can do in 2 to 3 steps. I will do till here. I will do till the path difference, because further part will be the same one only. So we have the alternate method. From this diagram I can derive the path difference. This is the path difference once again in this diagram. So I will do one thing here. It is again, the diagram part is the same. Instead of fringe width x we are taking, there we were taken as y, here we are taking x. And if it not necessary, I will change it by y. This is y. Y is the fringe width. So what will be condition for the formation of fringe width? ऑलरेडी वी नो कि 2 सोर्सेज मस्ट बी देयर, तो यहाँ सोर्स है, ये एक पाथ है एंड दिस इज अनदर पाथ, एंड एज विल ड्रॉ द परपेंडिकुलर फ्रॉम हियर, तो ये हमारा पाथ डिफरेंस हो गया. नाउ पाथ डिफरेंस इज S2A. S2A is path difference and S2P minus S1P, sorry, S2P minus S1P, yeah, correct. This is the path difference, which is S2A. It is the path difference whatever is to be calculated, यही हमें कैलकुलेट करना है. एंड वी हैव once again this term, this is of course D, distance, capital D is the distance between two slits. This is fringe width. I will write capital D is the distance between slit and screen, distance between slit and screen. And what is small d? Small d is the distance between two slits, दो स्लिट के बीच का डिस्टेंस है, S2, S1, S2, this is D. Now I will take triangle. I will I will point over here that diagram, so it could be easy for us. Yes. Now we will consider two triangles. हम लोग दो ट्रायंगल ले रहे हैं. One triangle is this one, bigger one, this triangle. In triangle COP, first case we are taking. In triangle COP, in this triangle we are going to take the tan theta. If we are taking tan theta, so what will happen? So take tan theta. Once again we are taking this triangle, and theta is here. Tan theta will be what? Opposite upon adjacent. So y by d. Directly I will write OP upon OC. This will be OP upon OC, but OP is y by OC is d, y by d. So this we will take one of the equation. Tan theta is close the theta, it is y by d, sorry, it is close to theta, it is y by d. I will write this as equation 1, and here I will write for small angle theta, because we know sin 0 is 0, tan 0 is also 0. If theta is very small, so tan theta can be considered as theta only. That we have written. This is equation 1. Now in this triangle only, in this triangle we'll take one more thing. In triangle S1A S2. Now in triangle S1A S2. Now in triangle, which one? S1A S2. S1A S2. In this triangle, what we will get? We have to take sin theta. Sin theta. What will be sin theta? Is opposite upon hypotenuse. So opposite is S2A, which is path difference, and this is D. So I can write it as S2A upon S1 S2, which is S2A upon S1 S2 is small d. So we can write this as, since we can write sin theta is close to theta. Once again, if theta is very small, then that will be close to theta, and it will be S2a upon d. This I will take as equation 2. So as we'll compare the equation 1 and 2, will get something. क्या मिलेगा हमें? हमें मिलेगा, we will get something, and क्या मिलेगा हमें? Now here both the terms are theta, so we can equate the equation 1 and 2. RHS we can equate, so we can write equating equation 1 and 2, equating equation 1 and 2, so we can write equating, now equating equation 1 and 2 will get y by d is equals to S2a by small d. So S2a will be y d by capital D, and S2a is nothing but the path difference. S2a is nothing but path difference, and we were supposed to calculate the path difference. So we can say path difference is equals to y d by capital D. So this is the derivation for the path difference. Whatever we were did in this method also, हमें यहाँ पे भी वही मिला था फर्स्ट मेथड में, एंड ये जो है आई कैन से कि ये जो है ये अल्टरनेट मेथड है, अल्टरनेट मेथड, एंड दिस मेथड इज़ वेरी इजी. यू कैन चूज बोथ द मेथड्स जो आपके लिए इजी हो. इट इज़ माई रिस्पॉन्सिबिलिटी टू टेल यू द easiest method, and both possible methods are there. यहाँ आगे हम लोग फिर से for constructive interference and for destructive interference, for constructive interference path difference is equals to even multiple of lambda by 2, तो constructive के लिए condition हो जाएगा, and for destructive if we have to write then it will be odd multiple of lambda by 2. So I hope entire derivation and concept of the interference of light, whatever I have explained, that everybody have understood. यहाँ पे मैं फिर से बता दूँ कि इंटरफेरेंस होता क्या है. ये डेफिनेशन हमने नहीं बताया. अपार्ट फ्रॉम दैट एवरीथिंग आई हैव एक्सप्लेन. तो डेफिनेशन क्या है इंटरफेरेंस का? इट इज़ द रीडिस्ट्रीब्यूशन ऑफ लाइट इंटेंसिटी ड्यू टू सुपरपोजिशन ऑफ टू लाइट वेव्स इज कॉल्ड द इंटरफेरेंस ऑफ लाइट. तो एक सोर्स ये है, दूसरा ये है, यहाँ से लाइट जा रहा है, यहाँ से लाइट जा रहा है, दूसरा जहाँ पे दोनों मिलते हैं यहाँ पे रीडिस्ट्रीब्यूट हो रहे हैं. रीडिस्ट्रीब्यूशन ऑफ लाइट इंटेंसिटी ड्यू टू सुपरपोजिशन ऑफ टू वेव्स. एक वेव यहाँ है, यहाँ से जा रहा है, दूसरा यहाँ से जा रहा है. इज कॉल्ड द इंटरफेरेंस ऑफ लाइट. आई होप अभी ये पार्ट बहुत बेटर वे से समझ में आया होगा बिकॉज ऑफ दिस डेरिवेशन वॉट एवर वी डिड. So I will request to everyone, please वीडियो को लाइक करिए, चैनल को सब्सक्राइब करिए, और जितना पॉसिबल हो सकता है आप वीडियो को शेयर करिए अगर आपके लिए यूज़फुल है तो. थैंक्स फॉर वॉचिंग दिस वीडियो. थैंक यू वेरी मच.